For decades, schools have relied on a very practical model. Teach the chapter, solve likely questions, practice previous papers, give suggested answers, revise the most expected patterns. There was nothing irrational about this. When questions were pattern driven, this produced results. A student who practiced enough often scored well because the student learned how to recognize the structure and reproduce a familiar method. That is exactly how schools built reliable board outcomes. Now ask what changes when the question becomes less predictable. Like a cab company charges a fixed booking fee and a per kilometer amount. One ride of 8 kilometers costs 124 rupees and another ride of 14 kilometers costs 196 rupees. They might ask find the booking fee and the per kilometer charge. Then predict the cost of a 20 kilometer ride. Now the student has to identify variables, form equations, solve them correctly, and then interpret what the numbers mean. Mere drill is no longer enough. Earlier, a question might be direct. In triangle ABC, angle B is 65 degrees, angle C is 45 degrees, find angle A. But the transformed version can combine older ideas in one diagram. At point O, two lines intersect. In triangle AOB, side AB is extended to C. One obtuse angle at O is 110 degrees and the exterior angle OBC is 125 degrees. Find angle BAO. Now to solve that well, the student has to know that the acute angle at O is 70 degrees, that the interior angle at B is 55 degrees, and then use the angle sum property of a triangle. That is not one prepared trick. That is connected understanding. Vertically opposite angles, linear pair logic, exterior-interior relation, and triangle angle sum working together. Now science is also moving in the same direction. Earlier, students would often get marks with answers like state Newton's first law of motion or say define inertia. A memorized definition could carry that answer. Now the transformed version may look like this. A passenger standing in a bus falls backward when the bus starts suddenly, but lurches forward when the bus stops suddenly. Explain both using the same scientific idea. Now what happens? The student must do more than recite a law. The student has to understand inertia, connect it to motion in two different situations, and explain cause and effect in words. That is why the real question is no longer did you study this. In fact, they're conducting open book exams. So then the question will be, do you actually understand this? That is the break. Important questions do not become useless. Revision also does not become useless. Practice does not become useless. But prediction becomes less reliable. And the moment prediction becomes less reliable, your classroom has to shift from teaching how to answer this question to teaching why this concept works, where it applies, where it breaks, and what earlier ideas support it. Now that takes more time because you need to give more examples, more explanation, you have to be more patient, but the timetable has not expanded, it's still 40 minutes. This is why schools may start noticing slower pace, wider performance variation, and fewer effortless high scorers. And this is also why the story cannot be understood only from class 9 onwards, because the ground under class 9 had already started moving earlier, if you remember. That's the next thing schools need to see clearly.